Hello, greetings, welcome to this three-part series on helicopter bungee jumping. Yeah, I wish. So this is problem 3.16c from the chapter on inductive definitions of sets. Yeah, so what's the deal with an inductive definition? Well, it's basically this. If I give you an x in some particular set, what do you have to do to get the next x or x's in that set? So for this particular problem, our set is a set of strings that have the form a to the 2n plus 1. And so if we just we look down here, we can just plug in some n's and sort of see, we can get an order of the elements in our set. So if we just plug in 0 to n, we get a to the 1, which is just a. If we plug in 1 to n, we get a to the third. 2, we get a to the fifth. And so what our actual answer is, the proper answer, if you look in the back of the textbook, what you should write on the test if we have a question like this on the test, is something like this. The basis is a, whatever we plug in, whatever we get when we just plug in 0 for n. And then the induction is, if x is an s, then AAX is an s, right? So this one here is an x and s. The next one is AAX. The one after that is AAX. Make sense? Hopefully it does. But the tricky part is an induction may not be linear. It may be binary or worse. This is problem 3.1.6g, and this is a to the m, b to the n. I think this is actually one I talked about in class one time. So where n is at least 0, or sorry, where n is greater than 0. So m can be 0, but n has to be at least 1. So that means our basis is b, b to the 1. But then after that, any combination of a's before that b or b's after that a, or b's after the starting b, is good. So our basis is b, then we can have bb, that's in our set. Then we can have ab, is also in our set. Then we can just, add a b onto the end of that, or an a onto the front, and so on. So our proper answer is this. Our basis is b is a subset in S, and then our induction is, if x is an S, then AX and XB are an S, right? So you can just pick any of these elements in our set, and you can get 2 more elements in the set by just adding an A in front and a B in the back, and it doesn't matter what element in the set you pick. Cool. All right, see you in part 2.